The notation f of x declares the name of a function to be f and the independent variable to be x. The name of the function allows us to distinguish it from other functions. We're going to choose a specific value of the independent variable from the domain. And what we're going to do is we're going to map from these, or we're going to assign these values in the domain, values from another set called the range. The function is what we're going to use to assign those values. So x is a value from the domain, and f of x is the value that the function assigns to the value from the domain in the range. In this case, let's take a look at a function f that assigns the value of 2, 5. So the value 5 gets assigned to the domain member 2, and that creates a disordered pair. Also 4 will get assigned a y value of 10. So from the domain you choose 4 and you'll get assigned the dependent variable 10. And 5 will also be assigned to 10, and 11 will be assigned -7. As long as everything in the domain has a clearly defined element that is assigned to in the range, then the function is well defined. We can also represent the exact same function, the exact same relationship here with a table. So this table has the exact same relationship described. 2 gets assigned a value of 5, 4 gets assigned a value of 10, 5 also gets assigned a value of 10, and 11 gets assigned a value of -7. The process of combining functions so that the output of one function becomes the input of the other function is known as a composition of functions. The resulting function is known as a composite function. This combination is represented by the notation g o f of x. So you read this, the g of the f of x. And it's the result of plugging the output from f of x in as the input to g of x. So whatever we get out of f when we plug in x, we're going to use that as the input for g. And it kind of looks like this. So for instance, if we were going to try to find the g of f of 4, the first thing we would need to do is figure out what the function f assigns to a value of 4 from its domain. Well, it turns out that 4 is being assigned a value of 10. So the f of 4, which is the first thing we need, is 10. Now that we know the f of 4 is 10, we know that the g of f of 4 is just the g of 10, because the f of 4 is 10. Now I just need to know what value the function g assigns to 10. So it seems as though g is assigning the number 23 to the value 10 in its domain. So the g of 10 is 23. And since the g of 10 is 23, that means the g of the f of 4 is 23. So here we have two tables. We have x and the f of x. We have x and the g of x. We're going to find the g of f of 11. So first we're going to find the f of 11, and we're going to plug that value in as the domain of g. So first I find the f of 11 by going into the domain of f, identifying the element 11 here, and then finding the value that is assigned, which is -7. So I find out that the f of 11 is -7. Now that I have that the f of 11 is -7, I need to find the g of -7. So the g of -7, then I just go to the domain of g, and I identify what g assigns to the value -7, and it turns out it assigns 12 to the value -7. So the g of -7 is 12, which means that the g of the f of 11 is just 12. So with the graphs, pretty much the same thing. If you're looking for the g of the f of -3, first you're going to go to the function called f, the inner function, and you're going to find the f of -3. Then you're going to take the answer from that and plug it into the function g, basically go to the domain of g, and find out what g maps that number to. So first we'll find the f of -3. The f of -3 means go to the domain of f and find the number -3, find the ordered pair that it maps to, or find the ordered pair that is associated with it, and then look for the y value of that ordered pair. Y value of that ordered pair is 4. So now that I know the f of -3 is 4, I'm looking now for the g of 4. So the g of 4 means I go into the domain of G, here in the domain of G, I'm identifying the number 4. Then from 4, I'm finding the associated ordered pair, and then finding the Y value of that ordered pair. And it turns out the Y value of that ordered pair is 8. So the G of 4 is 8, meaning that the G of the f of -3 is 8. So here we have two expressions, two functions. The f of g of x is the f of the g of x. We're plugging g of x into f. Here's g of x. I'm just going to replace the x here that's being squared with -5x plus 13. So this expression represents the f of the g of x. To find the f of the g of 3, I just need to replace the x's here with 3. So the f of the g of 3 is this expression. All I have to do is work out this arithmetic. When I work out the inside of the parentheses here, remember, that's the g of x. So the inside, the red part here, is going to be the g of 3 when I find it. So first I multiply -5 by 3 to get -15. Then -15 plus 13 is -2. -2 squared is 4. And then 2 times 4 is 8. 8 minus 3 will give me 5 finally. So that I have that the f of the g of 3 is 5. We just found the f of the g of 3. Let's see if that's the same as the g of the f of 3. Let's see if composition is commutative, basically. Here's the definition of the g of the f of x. You're going to plug f into g this time. So we're replacing the x here with that expression, 2x squared minus 3. So to find the g of the f of 3, I'm just going to plug in 3 for x in the innermost thing here. And then I'm going to follow the order of operation to simplify this. So I'll do 3 squared is 9. 2 times 9 is 18. Then 18 minus 3 is 15. And 15 times -5 will be -75. Once I've done everything inside of that parenthesis and the multiplication, now it's -75 plus 13, which gives me -62. So the f of the g of 3 is 5, while the g of the f of 3 is -62. So it turns out that the composition of functions is not commutative. If you take the two functions and switch them around, you will get different answers. Now let's talk about the domain of a composition. Here we're given the function f of x and g of x. We're asked to find the f of the g of x and its domain. Well, the f of the g of x is what I get when I plug the expression g of x into the function f. So I'm going to take this expression here and I'm going to replace x with the square root of x minus 2, which is what I have here. To get rid of that radical from the denominator, we're going to multiply the top and bottom of this fraction by the conjugate of the square root of x minus 2 plus 5, which is the square root of x minus 2 minus 5. On top is just going to be -2 times the square root of x minus 2 minus 5. On the bottom, when I multiply the square root of x minus 2 by the square root of x minus 2, the square roots and the squares cancel, and I'll just get x minus 2. The outside times the outside is going to give me -5 times the square root of x minus 2. The inside times the inside is going to be +5 times the square root of x minus 2, and those are going to cancel. And finally, +5 times -5 will give me -25. Once I've done that, I'm going to just combine these two like terms to get this expression, x minus 27 on the bottom, and I distribute on top -2 times the square root of x minus 2, and -2 times -5. So this is the f of the g of x. All I need to do now is find its domain. The domain of a composition of f and g is all the x values such that x is in the domain of g and g of x is in the domain of f. So basically you have to make sure that whatever value you choose for the independent variable of the innermost function, g in this case, is actually in the domain of g. Then once you get an answer for g, you have to make sure that answer is in the domain of f. For the value of x to be in the domain of g, so here's g, you can't have any negative numbers, because when you take the square root of a negative number, you get imaginary answers, which we're looking for real numbers as the outputs here. for a value of x to be in the domain of g, x minus 2, the radicand there, has to be a non-negative number. It cannot be negative. Another way of saying that is to say that x minus 2 has to be greater than or equal to 0, and then we can solve this inequality. By adding 2 to both sides, we get that x is greater than or equal to 2. The domain of this entire composition cannot be any bigger than this. This is the starting point for the domain of the innermost function. Once we know the domain of the innermost function, we have to make sure that the output of that innermost function is in the domain of the outer function, in this case f. So basically I have to make sure that g is in the domain of f. For a value of g to be in the domain of f, g plus 5, which is the denominator, cannot be 0 because you can't have 0 in the denominator. Saying that g plus 5 cannot be 0, well, you can write that this way, this inequality. G plus 5 is not 0. Solving this inequality just requires that I subtract 5 from both sides. I'll get g is not equal to negative 5. And then I'll remember that g is actually this expression with independent variable x. And I can come up with how this relates to x by replacing g with the square root of x minus 2. Now to solve this inequality, I need to get rid of the square root, and I do that by squaring both sides. So I square both sides, the square root and the square cancels, and negative 5 squared is 25. So I get this new inequality, and I add 2 to both sides to get that x is 27. So now here's what I know. X cannot be 27, and x also has to be greater than or equal to 2. So I need every number between 2 and 27, including 2. Then I need every number to the right of 27. That interval is described like this. Because x has to be greater than or equal to 2 and x cannot be 27, we're looking at the domain of FOG to be this interval. Everything from 2 to 27, and we include 2 with the bracket, but exclude 27 with the parenthesis. The union of that set with everything from 27 to infinity, and of course we're excluding 27 here too. Let's look at the GOF. The domain of the composite function GOF is all x's such that x is in the domain of f and f of x is in the domain of g. So let's find the domain of GOF instead. So if we're finding the domain of GOF, the first thing we have to do is make sure that x is in the domain of the inside function f. So we have to make sure that we know the domain of f. For a value of x to be in the domain of f, x plus 5 cannot be 0. We know we can write that as just x plus 5 is not equal to 0. This inequality will be a representation of the domain of f. So solving it is just a matter of subtracting 5 from both sides. And then I just describe this as an interval. It will be everything to the left of negative 5 union everything to the right of negative 5. So basically we're just excluding negative 5 here. This is every number except negative 5. Now I need to make sure that the value of f that I get is in the domain of g. So for a value of f to be in the domain of g, f minus 2 must be a non-negative number, because remember we're only taking the square roots of positives, or 0 if we want real numbers for answers. That can be written as f minus 2 is greater than or equal to 0. It has to be non-negative. I can solve this for f by adding 2 to both sides. I'll get this. And then I'll remember that f is actually equal to this. So I would replace f with negative 2 over x plus 5. So I get negative 2 over x plus 5 is greater than or equal to 2. And to solve this, we can cross multiply. When we cross multiply, we get negative 2 times 1, which is negative 2, is greater than or equal to 2 times x plus 5. And to solve this equation, I can divide both sides by 2 to get negative 1 is greater than or equal to x plus 5. And then I can subtract 5 from both sides to get negative 6 is greater than or equal to x, which means the exact same thing as x is less than or equal to negative 6. So I have that x cannot be 5, but x also has to be less than or equal to negative 6. And because x has to be less than or equal to negative 6 and x cannot be negative 5, the domain of G of f is just the interval from negative infinity to negative 6, including negative 6. Basically, all x's less than or equal to negative 6.